Hello and welcome to day 4 of my Advent of Code 2020 series. So if you have missed any of the previous days, be sure to check out the Advent of Code playlist right up here with all of those, and be sure to get subscribed so you don't miss any future days or any other videos from me. So today's problem is called passport processing, and the backstory to it is we arrive at the airport, but their automatic passport scanners are down, and we need to fix them. So the idea for part 1 is essentially we need to make sure that all of these fields, except for CID, because we don't want them to check country IDs so that our North Pole ID will work as well, are available in each passport that we're given. So the data format for our input now is this sort of batch file thing right here, where we have key value pairs, which are composed of things that are separated by colons, and each of those are split by either spaces or new lines, and each passport is split with a blank line in between. So this changes how we're going to read our input a little bit, obviously. And essentially what we want to do is check how many passports are valid by checking the ones that have all of those fields, except we don't care if they're CID or not because we don't want to be checking for CID for our own purposes. So I'm going to go ahead and jump into my code in about a second, so please pause the video here if you haven't given this a try on your own yet, and then hop back in. Okay, so jumping over to our code here, you can see first I had to switch how we're reading our input slightly because I wanted to split on double new lines instead of just regular new lines as we have been doing in the past. So by doing this, we are splitting into our actual individual passports instead of lines, because those lines might just be fragments of passports, as we saw before, with some passports being spread across multiple lines. So once we do that, we can go ahead and pass it into our part 1 solver function. So here what I did is first I initialize a set, and that set contains all of the fields that are needed for a passport to be considered valid. So this is all of the fields we saw earlier, except for I excluded CID. And now what we can do is we have count equals 0. We're just going to initialize our count, and we start looping through our passports. So what we do on each of those passports is we have this line right here, and I'm going to break this down a little bit for you guys. So going to our innermost thing first, we have this map function, and what map does is it takes a function and an iterator, and it returns a map object, which is similar to a list or anything like that, where it has applied every single thing in the iterator. It has applied the function to it. So here our iterator is passport.split. Remember, we have passports that are spanning multiple lines, so we are just using a bare split because we want to split on spaces or tabs if they're in there, I didn't check, and new lines, especially new lines. That's our main problem here, so that's why we do split on all white space. So then for every single element in there, what the map function does is it applies this function right here to each element there. So this is a lambda function, which is essentially a shorthand way of writing a function instead of having to sort of write out a whole def thing and have it named and have it taking up space all the time. So here our lambda function, the way that you can read this is whatever's on this side of the colon is our input, and then whatever is on this side of the colon here is our return value. So for every single thing that we're getting in from this passport.split, we are then splitting it further on the colon, because remember we have key value pairs separated by colons, and we're just taking the keys because that's all we care about for checking if those keys are present. So then once we have that, we just cast that map object to a set instead, because sets have this very handy isSuperset function. So what a superset is it's a set that contains at least all of the items in a different set. So here what we're doing is we're checking if keys is a superset of required. So that means, does keys contain every single thing in required? So if we go ahead through there, and the reason why I didn't just check if the two were equal is because keys may or may not have CID. So technically what I could do is just remove CID from the list of keys if it's present and then check if they're equal, but I think a superset is much more elegant anyway, and there may be situations where, if you can think of it in real life, passports may have other fields that just aren't required. There might be a bunch more of them. I didn't check the input data to see if that's actually the case in this input data, but I thought that would be a little bit cleaner. And then for every case where that is true, we increment the count, and then finally we return the count. So that got me my correct answer. For me, it was 202. And now we can go ahead and jump into part 2. So first, looking at the description of part 2, we can see this is great, but the issue is that they need to add data validation because there are people with invalid passports now who are getting through. Luckily, they didn't realize they're a little CID scam, but they are noticing the other things with people with invalid birth years, for instance. So what we can go ahead and check right here is we have all of these things. Our job is to count all the passports where those fields are both present and valid according to these rules right here. So I recommend you go ahead and give this a try. There are a lot of different approaches here that I would consider to be really like good as options. There have been a few problems in the past where I feel like the other sort of things are suboptimal, but this I could imagine a lot of different ways to solve. So go ahead and solve that, and then you can check back to see the solution I landed on, and I'll also talk about some other options. So pause the video now if you haven't done the problem yet, and we're going to jump into the code right about now. Okay, so the first thing I did is I implemented this key filter function, and if you'll realize, this is incredibly similar to our part 1 function, but instead of just incrementing a count every time, what I'm doing is I'm building each thing into a dictionary, and then I am adding that to a list of valid passports, and then we're returning that list. So to just break down the part that's different here is we are, instead of just creating a set of the fields that are present, I'm instead creating a dictionary with this dictionary comprehension right here, which I will explain right now. So the way to read a dictionary comprehension, you may have seen list comprehensions in the past. This is slightly different. So the way to read a dictionary comprehension is we have a colon here, and what that is saying is this right here is our key, and this right here is our value, and then just as you've probably seen in any other comprehension, if you've done comprehensions in Python, if not, then I'll explain this a little bit, is we have this for loop syntax right here. So the way to read this is this for loop is what's happening, and we're saying for pair in passport.split. So remember, passport.split is containing all of those colon pairs. And then what I'm doing here in this dictionary comprehension, just so that I didn't have to spread this into like a separate loop or something like that, I thought it was a bit cleaner to just do it in a dictionary. So what we did is we are doing pair.split on that colon again, but this time we're not just saving the first element, we are saving the first element as a key, and we're assigning the second element to it. So this will build up our dictionary. So now our check is slightly different too, because we're doing the set of passDict.keys, because keys is going to contain those keys that we wanted before. So we're casting that into a set and checking if that's a superset, and if so, we are appending it. So if you're having this function anyway, you could change your part 1 function to use this as well. So I wrote a little alternative part 1 here, where you just filter the keys and then return the length of that list that you get back. But obviously there would be no reason for you to preempt that you would have to do this ahead of time. So for part 1, it probably makes more sense to do it directly. But if you have this function anyway, because you're doing part 2, then you could also write part 1 like this. But now moving into our actual part 2, yeah, you'll see this is probably not the cleanest way to solve it, but I think it is probably the easiest to understand. So what we're doing for part 2 is we are establishing a count, as we normally do for things like this where we're counting things, and then we are looping through our key filter of passports. Remember, passports is just that bare list, and key filter is giving us back a list of dictionaries instead. And then I'll get back to why we have this try except in a second, but we have this giant if statement right here, which is essentially just checking all of our possible fields. So going through these, BYR had to be a number between 1920 and 2002, so I just cast it to an int, and then I check if it's between the two. IYR was the same, but for between 2010 and 2020. EYR, which I think was expiration, has to be between 2020 and 2030. So now we get into the more interesting one here. So height, it could either be in centimeters or inches. If it was in centimeters, so this is this first part of this expression, then we check if it's between 150 and 193. And what we have to do there is the little string slicing that I'm doing here. This right here is going to get the last 2 characters, because we're going from the second to last to the end of the list. And that's going to give us CM or IN. And then right here, we're slicing until the last 2 characters of the list, so that we just get the number that comes before the units, and we check if that's between 150 and 193. So then we have pretty much the same thing for inches, except for the range has to be between 59 and 76. So then this one statement here is what's checking if our height is valid. So on to the next statement, we're checking if hair color is valid. So hair color, for some reason, is a hexadecimal number. I've never seen hair color quantified like that, but okay. and it has to start with a pound sign right here. So first we check if the first character is a pound sign. This was necessary, at least in my input. I got the wrong answer when I didn't include that at first. And then our second thing that we have to check is this right here, which I will explain is pretty much checking if this thing is a valid hexadecimal number. So the way that I'm doing this is there are a few handy built-in functions in Python that are good for dealing with this sort of thing. So first I'm checking int of passDict HCL1 onward. Remember, that's to get rid of this pound symbol right here. And I passed it a second parameter of 16. So this second parameter that you can pass to int represents the base. So here I'm saying parse this string as a base 16 number, which is a hexadecimal number. So then the hex function can take in an integer and give back a hex string representation of it. So then I'm taking that integer and I'm turning it back into a hex string. So what I'm doing here is essentially this will fail if this is not a hexadecimal number, because first I'm checking if it's a hexadecimal number by casting it to a hexadecimal number, and then I'm turning it back into a hexadecimal number to make sure that those values stay the same. So then we pass it back into a hexadecimal number. So Python has hexadecimal numbers starting with 0x, as you see here. So I slice off that 0x and I check if that is equal to everything but the pound symbol in the original passDict thing that we're given. So that is dealing with the hair color in hexadecimal. So then we have eye color. So eye color, it just gave us a set of things and it had to be one of those. So I just checked if it's in a set of all of those possible options. So then we have the last thing is this PID here, and that PID has to be a number of length 9. So what I do to check that is we check if the length is indeed 9, and then we check if every character in it is numeric. So the reason I did this instead of trying to like cast it to an int or something is because it could have leading zeros. So I decided this would be a much better way to deal with all of those issues. And if all of those test cases pass, then we add 1. So I also encased all of this in a try except block, because you might have some cases where one of these tests fails, not because it's like outside of the range. Let's take birth year, for instance. You might have a birth year that is invalid, not because it's like 1919 or 2003 or something like that, but because it's like potato. If you get potato, then you can't turn potato into an integer. So this is just going to fail, but that is not a reason for a program to fail. It's just a reason to say that passport is invalid anyway. So I just put it in a try except block. So we'll only increment in the case where all of these pass and also everything here is valid. Otherwise, we'll just continue to the next object in the loop. So then once we check all of those things, we can go ahead and return our count. And that gave me a correct answer, which for my data set was 137. So I do want to talk about this part 2 problem a little bit more. If you were just here to see my answer, you can go ahead and click off now. Be sure to subscribe and stay tuned for future episodes. But I do want to talk a little bit more about this part 2 problem. So this is the first sort of problem I've seen this year that really does have a bunch of different really great ways to solve them that are all, I think, in my mind, equally clean and interesting. So another option you could do here is pretty much all of these could be turned into regular expressions instead, because they're essentially string parsing. So for this first one, you could just check for 4 integer digits and add a length of 4. So that would be something like this. You would have like 0 to 9, or in this case, we have hard bounds. So you could do this as like 19, and then what's this going to be? 2 to 9, and then what's it called? And then after that, it's going to be 0 to 9, and then you could have or 20, 0 to 9, no, less than 20, okay, so 0 to 2, and then just add a length check for 4, just to make sure it's not any longer. So you could write a regular expression like this. You could do that for all of the integer ones. Here you could just have an or, where if it matches CM, then you check an integer range like this for this, and if it ends in IN, you check an integer range for the other part like this. And then, yeah, for hex, there's also very trivial thing of the same format that you could do. Here, you could just OR all of these strings together. And then here, you could just have a numeric check with length 9 of a bunch of 0 to 9s. So that's another option. You could do this through regular expressions. I decided not to do that because I feel like fewer people know regular expressions. And I wanted this video to be as accessible as possible for as many people as possible. Another thing you could do is obviously break all of these tests out into separate functions. That may make your code a little bit more readable at a glance for people to understand what you're checking. But pretty much all of these are one-liners anyway, so I decided against that because this is just the semantic in my opinion. And doing that is just requiring you to write a lot more code for no reason. Although it technically may be more extensible in the future if you put all of those objects into a class or something like that, have a constructor that takes in the string, builds it into the dictionary if possible, checks all of those, and then provides that as a Boolean. That's another option. There are a lot of great ways to solve this problem pretty much, and do whichever one you feel most comfortable with. I recommend for this one even trying a few different things out just to get exposure to different sort of methods for this sort of thing. I feel like this is a really good problem for that because the actual logic is relatively trivial, but there are a lot of really cool implementations you could build. So that's going to be all from me for today. Thank you so much for watching. Be sure to check out the other days of Advent of Code that I've done so far up in this playlist right here, and get subscribed so you don't miss any future days. It definitely looks like these problems are getting a bit more interesting, so get ready for those, and I will see you in the next one. Goodbye.